continuing on with more factoring questions. It says factor completely, a squared plus 9. It looks a bit like difference of squares, right? I've got a perfect square here and a perfect square here, but it's not a difference. If I try to recognize a squared plus 9, a times a, 3 times 3, so here's a plus 3, a minus 3. If I multiply that out, a times a minus 3a because it's negative, plus 3a because that's positive, plus 3 times negative 3, that gives me negative 9. These two terms do drop out, do cancel out. It adds up to 0a. 0 times a is 0. But then that becomes a minus 9. In order to get a plus 9 here, these have to both be positive or both be negative. But then if they're both the same sign, they're not going to add up to 0, so it doesn't work. So for the first time here, we just say the binomial is not factorable. Right? So we can move on. Next problem here, factor completely. X to the fourth is a pretty high degree, but they all have an x. Leading coefficient here is just 1, so there's no other common factor. So I'll factor out the x. X cubed, 3 is 1 less than 4, plus 9x, 1 is 1 less than 2, minus 2x squared. Well, that's interesting. I didn't notice this right away. It wasn't in standard form to begin with. It went fourth, second, third, first, out of order. That implies to me that this quadrinomial might be able to be factored by grouping. So x cubed plus 9x, that has an x in common. And negative 2x squared, no x in common, but does have a 2 in common, and they're both negative. Let me factor out that 2. X squared, 2 times 9 is 18. And the negative with the 2 times positive 9 gives me negative 18. Right? And here we go, x squared plus 9. That's the same as x squared plus 9. So this x out front is being multiplied by all of this, which is x squared plus 9, common factor, times x, and times negative 2. Now I don't need to put big parentheses around that product the way I had big parentheses here, because it's a product. Right? Multiplication is associative. If I have a times b times c, there's no need to emphasize that these two get multiplied first. I get the same result if I instead multiply those two first, however I rearrange it, right? So I don't need these parentheses here. Just select that one. Let's see if I can do this. No, that deleted the whole thing. I don't want to do that. All right, so I will just undo all of those things here. All right, x minus 2. There we go. All right, so here's my x times this factor times that factor. I did need the big parentheses here because this minus separated it out as two separate terms. And both of these terms together, all four of these terms together, are being multiplied by x. Again, this looks like difference of squares, except that it's not a difference. So I can't factor this factor any further. X is just by itself, x minus 2, nothing I can do. So x squared parentheses x squared plus 9, close the parentheses. Notice when I close the parentheses, that red disappears. You want to make sure you don't accidentally hit check answer at this point when you have neglected to close that parenthesis. Oh, something wrong here. Okay, alright, here in real time we can check our work, see what we did wrong. So, here's what we did wrong. This is just an x. I wrote x squared. Right, so in my haste, my overconfidence, I did not bother to double check that what I wrote on the computer was the same as what I had on my page. So now when I check the answer, it's correct. All right, another one with a higher degree, but all those v's cancel. I can get v to the third times 2 more v's to get v to the fifth, v to the third times 1 more v here, and plus v to the third times 25. So that v to the third is a common factor. I'm left with v squared minus 10v plus 25. And notice 25 is a perfect square. What squared gets you 25? 5 squared gets you 25. V squared is a perfect square. V squared is v squared. And if I multiply these, 5v, double that, I get 10v, except I want negative 10v, so that means I have to be doubling negative 5v. Negative 5 times negative 5 is still positive 25. This binomial cannot be factored any further, so we're done. V cubed v minus 5. And just double check. V cubed v minus 5. Yes, that checks out. No, it's not correct. Oh, silly me. I wrote it wrong here. Right. V minus 5 does not equal v squared minus 10v plus 25. V minus 5 squared is v squared minus 10v plus 25. 2 mistakes in a row. There we go. Maybe I need to take a break. Alright, here we go. We have a positive term first, and these other two are negative. So that might explain why they wrote it in that order. But it's pretty common to start with our highest degree, right? Signs aside, we want our leading term to lead. So I'm going to rewrite this with the negative 5v squared first, then my v term, then my 150, which is positive. And now I can factor out the common factor of 5, but because this leading coefficient is negative, I'm going to factor out a negative 5. Negative 5 times v squared is negative 5v squared. So this is now a positive v squared. Negative 5 times v is negative 5v. In order for this term to be negative, it's got to be negative times a positive. So this term becomes positive 1v. Now, in order to get a positive 150 here, it's got to be negative times a negative to get positive. 5 times 3 is 15, so 5 times 30 is 150. Now, I want to see, can I go further? Well, v squared, that's just v and v. 30 is not a perfect square, so I know it's not just going to be v plus something squared. It's also negative, right? So it can't be a perfect square trinomial with a negative. But 30, 3 times 10, 2 times 15. But I know I want a positive 1 here, so I'm going to do 5 and 6. To get a positive 1, it needs to be a positive 6 and a negative 5. How do I know the signs are opposite? I know the product is negative. So negative 5 times positive 6, negative 30. V times v, v squared, of course. Now, outer inner, positive 6v minus 5v. 6 minus 5 is 1. Positive v. There we go. So let's see if I can write it correctly this time. Negative 5 times v minus 5, v plus 6. Okay, get my groove back. Okay, t squared minus t plus 31. Done. Now, how did I do that so quickly? I recognize 31 is a prime number. If I'm looking at, let's change color because it's a different problem here. T squared, I thought I changed color. There we go. T squared minus t plus 31. The only way to get t squared is t times t. Right? That's pretty easy. But 31 is also really easy. It's a prime number. The only product of whole numbers that's going to get you to 31 is 1 times 31. And there's no way t plus 31t is going to get you negative 1t. Now, just because this is a prime number doesn't automatically mean that it's a prime. It's the fact that this middle term is not cooperating. If this had been minus 32t, then this would be the answer, right? Negative plus negative 31, negative 32. But it's not negative 32, it's negative 1. It's not going to work out. Not factorable. Good job. And it's giving us some advice even though we got it right. You should read those, but you can read them on your own time. All right, now here we get a ridiculous question. So first thing we notice, 5 ends with a 5. We have a common factor. So I can factor out the 5. W to the 4th minus 3,125 divided by 5. Well, 5 times 6 is 30. We just looked at that. 1 minus 0 is 1. Okay, bring down the 2. 5 goes into 12 twice. 5 times 2 is 10. 12 minus 10 is 2. Bring down the 5. I think I know where this is going. 5 goes into 25 5 times. So 5 times 625 is 3,125. Now, what they want you to notice here is that w to the 4th is a perfect square. Right? 2 times 2 is 4. So w squared squared is w to the 4th. 625 I recognize as 5 to the 4th power. So 625, by the exact same logic, is 5 squared squared. So I have a 5 common factor. Difference of squares. This thing in parentheses squared minus this thing in parentheses squared. So I get that thing plus this thing. And this thing minus this thing. W squared plus 5 squared, that's a sum. Can't do anything about that. 5 squared is 25. But here I have difference of squares again. So w plus 5, w minus 5. In fact, difference of fourths is always going to work out this way, right? A perfect fourth minus a perfect fourth will always end up as the sum of two perfect squares times the difference of two perfect squares, and then that difference of squares can get factored an additional time. So 5 w squared plus 25, and then w squared minus 25, which factors thusly. Okay. Okay, here's a multiple choice, which is even uglier than the one before it. 1 minus s to the 8th. Well, we just talked about perfect fourths, now we have perfect eighths. 2 times 4 is 8, so that's s to the 4th squared. 1 times 1 times 1 times 1 times 1 times 1, it's always going to be 1. Right? 1's a perfect everything. It's perfect square, perfect cubed, perfect fourth. So this is difference of squares. 1 plus s to the 4th, 1 minus s to the 4th. Same problem we did before, difference of fourths. So this 1 plus s to the 4th stays put. Here I have 1 plus s squared, 1 minus s squared. And then that 1 minus s squared is difference of squares. But instead of asking you to type all of this out, they just want us to find it. 1 plus s to the 4th, 1 plus s squared, 1 plus s, 1 minus s. Thankfully, they randomly decided to put it in spot A. Factor completely. This one's not factored completely. Right, that 1 minus s squared can be factored even further. Choice A. All right, here we're back to regular old problems. V to the 5th. V goes into all three of these 3 times. Didn't we already see this problem? I'll just go at regular speed here. So V squared, that's V and V. 18 could be 2 times 9. That reminds me of 11, right? 2 plus 9 is 11. So to get positive 18, they need the same sign. To get negative 11, there we go, right? Negative 9v minus 2v, negative 11v. And this is not difference of squares. It's just a plain v here. So we're done. V cubed. When you're typing these in, double check, make sure you're using the correct variable. You don't want to type in x when you mean to type in v. All right, well done. All right, this might take a little bit longer. Let's start the next video with this one.